In this video, we will continue to practice doing parallelogram proofs. Now, when we're talking about a parallelogram, there are 5 facts that we have to keep in mind. One is the definition of a parallelogram, which is opposite sides are parallel. That's the only one, that's the definition. But in addition to that, we have these 4 properties of a parallelogram. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So if any 4 of these show up, we basically just have to write the whole sentence. Like, for example, if I want to use the fact that this is a parallelogram to show that opposite sides are congruent, I'm going to say opposite sides of a parallelogram are congruent for the reason. If we're talking about opposite sides are parallel, then we can say definition of parallelogram. All right, for the first proof, we are given that this quadrilateral is a parallelogram, which means that I can use the definition of a parallelogram as well as these 4 properties. But what are we trying to prove? We're trying to prove that triangle AEB, all right, so here's triangle AEB, and we want to show that that is congruent to triangle CED. So here's triangle CED. Okay, so there are a variety of methods that I could use to prove that these are congruent. So one way I could prove these congruent would be to use the diagonals. So one of our properties is that the diagonals bisect each other. In other words, the diagonals cut each other in half. We could use that fact. Okay, so I could say that, let's see, look at these diagonals. One diagonal is DB. Okay, I feel like I should redraw this. So here's one diagonal. So I could say that DB, okay, and here's the other diagonal, DB and AC bisect each other. Okay. Now, what do I put for the reason? When I'm using one of these properties, I pretty much just have to write out this entire statement. So I'm just going to say the diagonals of a parallelogram bisect each other. That will just be the reason. All right, the diagonals of a parallelogram bisect each other. Okay. Next, I can go ahead and make the congruence statement. So because these bisect each other, then, for example, DE is going to be congruent to EB. So DE is congruent to EB. And that's just a definition of segment bisector. Okay, and at the same time, I can say that AE is congruent to EC. For the same reason, definition of segment bisector. Okay, and I have so many choices. I could use the vertical angles right now, or I could use the fact that opposite sides of a parallelogram are congruent. So since I really want to practice my parallelogram properties, I'm going to go ahead and use the opposite sides of a parallelogram. All right, so these will be congruent. Oh, you know what? I almost forgot that the two triangles that we're trying to show are congruent. Bye. Bye. All right, we're supposed to be doing these triangles. Okay, so for a moment there, I marked the wrong sides. I don't want these. Instead, I want these. 1, 2, 3, 1, 2, 3. Okay, so I could go ahead and say side DC is congruent to side AB, and it's because opposite sides of a parallelogram are congruent. So I could say opposite sides of a parallelogram are congruent. So if I take this approach, then the reason for the triangles to be congruent would be side, side, side. Okay? But I could have just as easily said that the vertical angles are equal, and then that would have been side, angle, side. Okay? I also could have used alternate interior angles. There's just so many ways to do it. So there's more than one right answer for sure. All right, just for the sake of knowledge, I want to do that same proof over again using a completely different method. All right, this time I'm going to use more parallel lines. So I still want to prove that the same two triangles are congruent. But if this is a parallelogram, then that means that, for example, side DC and side AB are parallel. So I could say DC is parallel to AB. All right, and that's just the definition of a parallelogram. All right, now the point of doing that is because of this. Once you highlight the parallel lines, if you draw the transversal like this, the corners of the Z are alternate interior angles. And if the lines are parallel, then these will be congruent. So I can mark these angles as congruent. So that means that I'm looking at angle DCA. So I could say angle DCA is congruent to angle BAC. All right, and these are alternate interior angles. So the reason will be the alternate interior angles theorem. Okay, now I could just as easily have, I could have drawn the other diagonal, all right, as my transversal. So this works just as well. That makes this backwards facing Z. So that means that this corner of the Z is congruent to this corner of the Z. These are also alternate interior angles of parallel lines. So I'm just going to name them congruent. So angle CDB is congruent to angle ABD. All right, it's the exact same reason. These are still alternate interior angles, so I'm just going to say this is the alternate interior angles theorem. Okay, So I've almost got enough information to prove that these two triangles are congruent. I've got two angles. Now, I wouldn't want to go for the vertical angles right now. Right? I could have done that instead of using one of these alternate interior angles. I could have done vertical angles. But if I did that now, that would be angle, angle, angle. That's not going to help me. So instead, this is what I'm going to do. I could say that this side, CD, is congruent to this side, AB. All right? So I could say DC is congruent to AB. And that's because these are opposite sides of a parallelogram. And we know that opposite sides of a parallelogram are congruent. Now that gives us enough information to say that the top triangle is congruent to the bottom triangle. But this time, because of the information that we chose, the reason will be angle, side, angle. Okay, so that's almost a completely different method for doing the same proof. Okay, I used a whole different set of information. So that's just to emphasize to you guys that there's more than one way to solve these things sometimes. Okay, moving on to the next proof. All we are given is that this is a parallelogram, which frees us to use the definition of a parallelogram and any of these four properties. All right, there will probably be multiple ways to solve this. What we're trying to prove is that triangle ABC, right, so here's triangle ABC, is congruent to triangle CDA. All right, we're trying to prove that these are congruent. Let's see what we've got. Okay, so let's get the given out of the way. So we can definitely say ABCD is a parallelogram. All right, that is given. Okay, I think I'm going to take a side approach to this. So for example, I should be able to say that this side is congruent to this side. And I could say, so that would be saying that AD is congruent to BC. And that's because opposite sides of a parallelogram are congruent. All right, can I abbreviate that enough to fit? Opposite sides of a parallelogram are congruent. All right, while I'm at it, I can go ahead and say this as well. This side should be congruent to that side. So I should be able to say that AB is congruent to DC. And again, that's because opposite sides of a parallelogram are congruent. All right, now of course I can then say that AC is congruent to AC because that is the shared side. So AC is congruent to AC, and that will be the reflexive property. All right, so now I have side, side, side. So now I can say triangle ABC is congruent to triangle CDA by side, side, side. Now, I want to show you another way I could have done the same proof. Here's another approach. I could have started off by saying that side DC is parallel to side AB. So I could have said side DC is parallel to AB. That's the definition of parallelogram. All right, now that I have those parallel sides, let's highlight them. All right, so these sides are parallel. If I also highlight the transversal, then it makes it clear which angles have to be congruent. These are alternate interior angles right here. And if the lines are parallel, these will be congruent. So angle DCA should be congruent to angle BAC. And that's because of the alternate interior angles theorem. Okay, now I can do the same thing with the other pair of sides. Okay, look at these sides. If this is a parallelogram, these will also be parallel. So I could also say that DA or AD is parallel to BC. And again, that would be the definition of parallelogram. Okay, and again, if I highlight the transversal, it really shows you which angles have to be congruent, because you want to look at the corners of the Z. So this angle will be congruent to this angle. Okay, so that's going to be angle DAC is congruent to angle BCA. And again, that is our alternate interior angles theorem. Okay, so now we have almost enough information to prove that these triangles are congruent, but we need to include the shared side. AC is congruent to AC. And that is the reflexive property. So if I'm going to take this approach, I'm going to need one extra box to finish this off, because in the end I need to be able to say that triangle ABC is congruent to triangle CDA, and this time it'll be because of angle side angle. All right, here comes the next proof. I'm noticing that this time we're not proving congruent triangles. We're proving specific segments are congruent. So I'm betting that in the end we're going to wind up using CPCTC. Corresponding parts of congruent triangles are congruent. That is my bet. But let's see how it goes. So first of all, we are given that YX is congruent to WX. So those are congruent. We're also given that ZX bisects angle YXW. Okay, that's this angle up here. So If ZX is a bisector, an angle bisector, that means these two angles will be congruent, all right? Because we're splitting angle YXW down the middle, and I get two congruent pieces. Okay. Let's write that down. Let's write down what we have so far. So for starters, we have YX is congruent to WX. Whoops. All right, that was just straight given. All right, now I marked these angles as congruent, but we're not given this congruency. We're not given this angle is congruent to that angle, given. Instead, we're given this information about a bisector. So this is going to take up 2 lines on this proof, all right, to get here. So I will state the given, and then I will state the make the congruence statement. So first I will say ZX bisects angle YXW. Okay, that's given. But then I can make the congruence statement. I can say angle YXZ is congruent to angle WXZ. And that's the definition of angle bisector. Okay. Let's pay careful attention to what our target is, what we are trying to prove. We are trying to prove that YZ is congruent to WZ. All right, so I have to think about what 2 triangles I need to prove congruent, because there are a lot of triangles in this picture. Am I trying to just prove these 2 little tiny triangles to be congruent at the top? No, because that would not involve these yellow sides down here that we need. So we must be trying to prove that the bigger triangles, like for example this triangle, okay, I'm going to erase this in a second, and this triangle, this must be what we are trying to prove. All right, the purple triangle and the green triangle, because these would be corresponding parts then. Okay, so keep that in mind. So for that reason, the next thing I'm going to do is I'm going to pick the shared side between those 2 triangles. And I'm going to say, look, this shared side is going to be the same for the triangle on the left and the triangle on the right. So I could say XZ is congruent to XZ. And that is your reflexive property at work. All right, now that gives me enough information to say that the entire left triangle is congruent to the entire right triangle. Okay, so I could say on the left over here I have triangle ZYX is congruent to triangle ZWX. All right, and that'll be because of side, angle, side. So finally, we can get to the specific piece we were trying to prove. All right, now that we have proven that the whole triangle is congruent, now we can pick any remaining corresponding parts, hint, hint, and we can say that these corresponding parts will be congruent. All right, because corresponding parts of congruent triangles will always be congruent. Okay, so we're supposed to use the given and anything else we can just know from the diagram to say why we can prove the two triangles are congruent, or we're going to say that they can't be proven congruent. Caution, we are either going to fill in the blanks or we will circle we can't prove they are congruent. On the last quiz I gave, I had some people circle this, all right, saying that it can't be proven, but then they would go ahead and say triangle ABC is congruent to triangle BAD or whatever. Okay, yeah, if you can't prove they're congruent, you shouldn't be filling anything in. You can't say, I can't prove they're congruent, and then say, this triangle is congruent to that triangle. That doesn't make any sense. So either fill in the blanks or circle this. Don't circle this and still fill in one of the blanks. Okay, anyways, I just had to get that off my chest. AB bisects angle DAC. All right, so first of all, here's angle DAC. And AB bisects that. All right, so this is the angle bisector, which means that it is split into two equal parts. So those angles are going to be congruent. Okay, we are also given that DB is congruent to CB. And we also know that the shared side is going to be equal for both. So looking at those markings, this is shaping up to be side-side angle. Side-side angle does not prove that triangles are congruent. So I'm going to circle we can't prove the triangles are congruent. And whatever you do, do not go and fill in a triangle on this first line. All right, or you will get the whole problem wrong if you do that. All right, moving on to the next one. We are given that DA is parallel to BC. So these are parallel, which indirectly tells me something. If these are parallel, okay, that's like this. And then here is my transversal. Then see the Z that's formed? When you have parallel lines, these alternate interior angles will be congruent. So we have that. In addition to that, DB is congruent to BC. Okay, DB and AC. Can I just Control Z that? DB is congruent to AC. Okay, and in addition to that, we can mark the shared side as congruent for both triangles. So, what do I have now? All right. This is the same situation as before. All right. Again, this is going to be side angle. All right. So again, we cannot prove that these triangles are congruent. So whatever you do, do not fill in any of this information up here. Do not put a congruency triangle right here. Are you guys seeing why this would not be side angle side? If you just look at one of these triangles at a time, look at these two sides. Do you see how the angle is not in the middle between the two sides? All right, so that's why it's not side angle side. All right, anyway, coming down to this bottom part. We are given triangle PQR is congruent to triangle STU. we also know this information right here. Circle the pair of lengths that must be the same. Let's see. PQ would be the same as ST. All right, so I see PQ. I do not see ST anywhere. Okay, what else you got? QR. QR. See how QR, that's the last two? QR should be the same as TU. All right, the last two and the last two. QR, TU. Okay, I see the pair. QR and TU should be congruent. Okay, so with that in mind, let's find the value of x. So QR should equal TU. So that means since QR is 8x minus 4, that should equal 7x plus 1. So I need to solve this equation. Let us subtract 7x from both sides. So that's going to leave x minus 4 is equal to 1. And now let's add 4 to both sides. So that gives us x is equal to 5. All right, so now we found the value of x. All right, so now we need to find the length of each of the lengths below. All right, so we found x. So let's go ahead and do QR and TU. Remember that x is 5. So if I substitute in 5 right here, okay, then that tells me that QR is going to be 8 times 5 minus 4. That is 40 minus 4, which is 36. All right, so QR is 36. Put a big old 36 right there. TU is equal to that. So TU is also going to be 36. Okay, let's see, what else can we do? So we did QR and we did TU. All right, US is 6x. So if x is 5, then that means that this is going to be 30, all right? 6 times 5. US and SU are the same thing. So SU, or US, is 30. Okay, let's see if US is the same thing as any other value. Okay, US or SU, that's the first and the last. So that should be the same thing as PR. Okay, so PR. So if SU is 30, then PR should also be 30. So that just leaves PQ and ST. Okay, so here's PQ. So if this is 5, then PQ is going to be 5 times 5 plus 7. So that's 25 plus 7. So that's going to be 32. So PQ is 32. Okay. Now, just to save myself a little bit of time, PQ should be the same thing as ST, the first two and the first two. So if this is 32, then this should also be 32. So ST should also be 32. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.